Did you know that the largest earthquake ever recorded on another planet was a magnitude 5 on Mars? Yes, you heard it right. This seismic event on our neighboring red planet, dubbed a Marsquake, was detected by NASA's InSight mission. This mission uses the Seismic Experiment for Interior Structure, or SEIS, the first seismometer ever to be deployed on an extraterrestrial world. Since its operation began 3 years ago, SEIS has recorded over 1,300 Marsquakes, but none have quite matched the intensity of this recent quake. What makes this discovery so significant is that the seismic waves passing through Mars's interior can reveal intricate details about its size, composition, and distribution of features. This assists us in understanding the formation and evolution of Mars. Imagine the possibilities that this startling fact opens up for us. A new realm of understanding not only our own planet, but also those beyond. Stay tuned for more intriguing facts about earthquakes here on Earth and beyond. Earthquakes aren't just limited to our planet, but what exactly causes these earth-shattering events? Well, to understand this, let's imagine the Earth as a giant jigsaw puzzle. This puzzle is made up of large pieces called tectonic plates. These plates aren't static, they're constantly moving, albeit very slowly, about as fast as your fingernails grow. The surface of our Earth is dynamic, always changing and reshaping itself. Now, where these plates meet, we have what we call fault lines. Think of them as the edges of the puzzle pieces. As these plates move, they often get stuck at their edges due to friction. But the plates are still trying to move, so stress builds up at these fault lines. Picture this. You're trying to push a heavy piece of furniture across a room. It's heavy, so it doesn't move easily, but you keep pushing. Suddenly, it gives way and lurches forward. That's a bit like what happens during an earthquake. The stuck plates finally give way, releasing the accumulated stress. This energy then travels through the Earth in the form of seismic waves, much like ripples spreading across a pond when you throw a stone into it. When these waves reach the surface, they shake the ground, and we feel it as an earthquake. It's important to note that not all earthquakes are created equal. The magnitude of an earthquake, or how powerful it is, depends on several factors, including the amount of stress released and how deep within the Earth the earthquake starts. There are also different types of earthquakes based on the movement of the tectonic plates. Some plates slide past each other, others collide, and some even move apart. Each type of movement results in a different kind of quake. Now that we understand the cause, let's explore the effects of earthquakes. Earthquakes can cause widespread destruction on Earth, but how do they do it? When tectonic plates beneath the Earth's surface shift, they release energy in the form of seismic waves. These waves travel through the Earth, shaking the ground and anything on top of it. This ground shaking can be gentle, barely noticeable, or it can be violent, toppling buildings and causing landslides. Landslides are a common secondary effect of earthquakes. When the ground shakes, it can destabilize slopes and trigger landslides, burying homes and blocking roads. A notable example is the 1959 Hebgen Lake earthquake in Montana, which triggered a massive landslide that killed 28 people and formed a new lake. Earthquakes can also cause tsunamis, giant ocean waves that can travel across entire oceans. When an earthquake occurs beneath the ocean floor, it can displace a large amount of water, creating a tsunami. The 2004 Indian Ocean earthquake and tsunami is a tragic example. The earthquake, one of the strongest ever recorded, triggered a series of devastating tsunamis that affected 14 countries and killed over 200,000 people. Another secondary effect of earthquakes is fire. When buildings collapse, gas lines can rupture and electrical lines can spark, igniting fires. The 1906 San Francisco earthquake is a prime example of this. The earthquake itself was devastating, but the fires that followed caused even more damage, burning for 3 days and destroying much of the city. Earthquakes can also have long-term effects on communities and economies. They can displace populations, destroy infrastructure, and disrupt vital services like water and electricity. Recovery can take years, even decades, and the cost can run into billions of dollars. As we see, earthquakes can be devastating, but can we predict them? Predicting earthquakes has long been a goal of scientists, but how close are we to achieving it? The journey to understand and predict earthquakes is as intriguing as it is challenging. Let's delve into this captivating subject. In the pursuit of predicting earthquakes, scientists employ a variety of tools and techniques. Seismographs, for instance, are devices that record the intensity, direction, and duration of seismic waves. These instruments provide valuable data that help scientists analyze the patterns and origins of earthquakes. Then, there's the fascinating field of paleoseismology. This involves studying geologic sediments and rocks to understand the history of earthquakes over thousands of years. By piecing together this historical puzzle, scientists hope to predict future seismic events. However, despite these technological advancements, predicting earthquakes with precision remains an elusive goal. The main challenge lies in the complex nature of earthquakes themselves. They are the result of geological processes that occur deep within the Earth's crust, where conditions are incredibly difficult to monitor. Moreover, each earthquake is unique with its own set of characteristics. This diversity makes it hard to establish a universal predictive model. While scientists can identify high-risk areas and provide a general timeline for potential seismic activity, pinpointing the exact time, location, and magnitude of an earthquake still remains out of reach. Nevertheless, the field of earthquake prediction is evolving rapidly. For example, NASA's InSight mission on Mars recently detected the largest extraterrestrial earthquake, or Marsquake, ever recorded. This achievement could offer new insights into the seismic activity of other planets, and potentially our own. While predicting earthquakes remains difficult, there are ways we can prepare for them. So, while we continue to strive for accurate predictions, it's crucial that we also focus on preparedness. After all, it's not just about knowing when an earthquake might occur, but also about knowing what to do when it does. Scene script. Earthquakes may be unpredictable, but that doesn't mean we can't be prepared. In the face of such powerful natural forces, preparation is our best defense. The first step is to create an emergency plan. This should outline safe places in your home, routes to exit your residence, and a meeting place for family members after an earthquake. Remember, during an earthquake, stay away from windows and anything that could fall, such as lighting fixtures or furniture. Next, assemble a disaster supply kit. It should include essentials like water, non-perishable food, a first aid kit, flashlights, and batteries. It's also a good idea to have a battery-operated or hand-crank radio to stay informed in case of power outages. Taking steps to make your home more resistant to earthquake damage is another crucial aspect of preparation. This process, known as retrofitting, can include bolting your house to its foundation and bracing walls. Ensuring heavy furniture and appliances are secured can also reduce the risk of injury. And let's not forget about earthquake insurance. Standard homeowners insurance typically does not cover earthquake damage, making it necessary to consider additional coverage. Earthquake insurance can help cover the cost of repairing or replacing your home and belongings after a quake. However, it's important to note that this type of insurance may not cover other earthquake-related incidents, like fires or floods, so it's worth discussing your options with an insurance provider. By being proactive, we can mitigate the potential harm earthquakes can cause. It's about understanding the risks, making a plan, and taking action. Remember, the goal isn't to eliminate the threat of earthquakes, it's to equip ourselves with the knowledge and tools to handle them when they occur. By being prepared, we can better protect ourselves and our loved ones during an earthquake. The study of earthquakes is an ongoing field of research with exciting potential. As we venture further into the 24th century, the integration of advanced technology and innovative methods promises to revolutionize our understanding of seismic activities. Imagine a world where we can monitor and analyze earthquakes not just on Earth, but on other celestial bodies as well. Take, for example, NASA's InSight mission on Mars, which detected the largest ever recorded extraterrestrial earthquake. This Marsquake provides invaluable insights into the geological activity and interior of Mars, opening new doors for interplanetary seismic studies. Moreover, the future of earthquake science extends beyond the realms of space. Earthquake insurance, a practical application of this field, is being reimagined to provide more comprehensive coverage. Advancements in this sector could lead to more affordable premiums and enhanced protection against earthquake-related damages. As we continue to learn more about earthquakes, we can better prepare for and mitigate their impacts. Thanks for joining us today on Facts and Quizzes, and don't forget to like, share, and subscribe for more intriguing content.